10, 9, 8.
More than a year and a half ago, on October 14th, 2024,
3, 2, 1. Ignition. And liftoff. Liftoff for Falcon Heavy with Europa Clipper.
the SpaceX Falcon Heavy rocket took to the skies over Florida. This 70-meter tall rocket, using the full power of all three boosters,
Europa Clipper, separation confirmed,
to send NASA's Europa Clipper spacecraft on its way to begin its years-long journey to one of Jupiter's best-known moons, Europa. This was just the 11th Falcon Heavy launch to date. A far more common sight is seeing SpaceX's Falcon 9 rocket, which has launched more than 630 times as of publishing this video. The Falcon Heavy, however, is a spectacle that can draw thousands to Brevard County, especially
watch as they touch down
when its two side boosters come back to land at Cape Canaveral Space Force Station. That will be the case with the upcoming launch of the Viasat 3 F3 satellite. The last time we did a video explicitly about SpaceX's Falcon Heavy rocket was back in July of 2023. And as you can imagine, there have been a number of developments concerning SpaceX's heavy lift rocket since then. Here's what you need to know.
3, 2, 1, 0. Ignition. Stop! Go Falcon Heavy!
The first flight of a Falcon Heavy was back in February of 2018. No customer payload was on board, but it did contain the Tesla Roadster belonging to SpaceX founder Elon Musk. We'll come back to that Roadster a little bit later. The mission also marked the first double landing of Falcon boosters back at the Cape. A little more than a year later, in April 2019,
2, 1, 0. Ignition. Liftoff.
came the launch of the Arabsat 6A mission for customer Arabsat. SpaceX was successful in initially landing all three of the boosters, but the core booster was lost at sea. A few months after that, in June 2019,
2, 1, 0. Ignition.
the Space Test Program 2, STP-2 for short, launched on behalf of the U.S. Air Force. It also carried a secondary payload called LightSail 2, a mission crowdfunded by the Planetary Society. Like with the Arabsat 6A mission, SpaceX once again tried to land the center booster, but this time it missed the drone ship entirely and was lost. It would be nearly 2.5 years before another mission needed the Falcon Heavy. That was the United States Space Force, or USSF, 44 mission. It was the first classified payload for a Falcon Heavy, and the first mission where SpaceX used the rocket to send a payload into a direct geosynchronous Earth orbit. So while the side boosters were recovered, there was no plan to try and save the center booster, tail number 1051. SpaceX has since foregone any attempts to recover the center booster. Those side boosters came into service again in January 2023 during the launch of the USSF 67 mission. Once again, the center core, this time B-1070, was expended, and the side boosters B-1064 and B-1065 returned to the Cape. 2023, in fact, was a pretty big year for the Falcon Heavy. After the USSF 67 mission in January, it was followed by the Viasat 3 Americas, the first fully expendable Falcon Heavy mission, and then the Jupiter 3/EchoStar 24 flight in July, which did see a recovery of the two side boosters, 1064 and 1065. Those boosters would then go on to return for a fourth time to support the launch of NASA's Psyche mission, a spacecraft designed to rendezvous with a metal-rich asteroid.
Psyche is an incredibly important mission for SpaceX. It is the first Falcon Heavy launch we're having for NASA, and it is also the first launch for SpaceX that has required what's called Category 3 certification. This is the highest tier of certification one can get on a launch vehicle. It demonstrates that the launch vehicle is ready for NASA's most important science missions. That means Falcon Heavy has been through the ringer, whether that's design reviews, qualification testing, acceptance testing, post-flight data reviews, independent verification and validation work. Falcon Heavy is ready, and we are so excited to have Falcon Heavy be supporting the Psyche mission.
The two side boosters, 1064 and 1065, returned yet again in December of that year to support the launch of the X-37B, a military spaceplane operated by the Department of the Air Force. Following a static fire test at Launch Complex 39A and after the rocket returned to the hangar, we spoke with Dr. Walt Lauderdale about what he and the U.S. Space Force were learning about working with this reusable heavy-lift rocket.
First mission I had a chance to do and we followed was STP-2 back in June of 2019, which was the first reuse of side cores after Arabsat 6. So we got our first look at that, but it's a little different kind of following along with our teammates elsewhere in SFC. But going into the campaigns, we had first flight hardware with SF-44 beginning of last November, and then we turned around 2 months later with reuse, and we're able to use those same cores again for SF-67, which was a terrific partnership, making sure that we could use that for the first time. And then we had planned to use them for the third time until we had to move our launch out of the summer. And they've since had an opportunity to be used with a commercial launch and then with NASA's Psyche mission. One of the things that was a benefit, and I can't remember if I touched on it before, GPS 36 had first been flown for a crew mission, and we took advantage of NASA's work in evaluating that booster, and we didn't repeat what we didn't need to. It was the first opportunity for us to actually benchmark our processes for nominal work against what NASA did, and it was a good collaboration with NASA. We were able to do something similar with NASA LSP, the Launch Services Program, for the work they did in evaluating the side cores after the commercial launch to get ready for Psyche. So we were able to use their work and input that us to make it a little simpler for us getting ready for this mission. So this will be a fifth flight for the boosters. It'll be, of course, the furthest number of flights for a side core for us. But it really sets the stage for some flexibility, reuse as a whole, because as busy as our manifest is going to be, and there's always the potential for the missions moving around, being confident in any of the boosters that are in SpaceX's inventory without us having to do a bunch of extra work is a tremendous benefit to us and to the warfighter in terms of putting that capability on orbit.
Engines full power and liftoff of Falcon Heavy.
As with previous missions, once again, after a good liftoff of the rocket,
Landing leg deploy.
the two side boosters safely landed back at landing zones 1 and 2 at Cape Canaveral.
Stage 2 is in terminal guidance.
Six months later, in June 2024,
2, 1.
the launch of the GOES-U spacecraft on behalf of the National Oceanic and Atmospheric Administration, or NOAA. NASA was responsible for procuring the Falcon Heavy as a launch vehicle as part of its Launch Services Program. Prior to the mission launching, Juliana Scheiman, SpaceX's Director of NASA Science Missions, described some of the unique properties of this mission for the Falcon Heavy.
The GOES spacecraft operates more than 35,000 kilometers above the surface of the Earth in an orbit called geostationary orbit. This is an incredibly high-energy orbit that necessitates an incredibly powerful rocket to get there. And it's this orbit that drives the extended payload deploy. So payload deploy for this mission will be 4.5 hours after liftoff. One of the other unique things about this mission is we partnered very closely with NASA and with Lockheed to leverage Falcon Heavy's performance. So much so that this launch of GOES-U will be the most performance launch. We'll have the most performance a GOES spacecraft has seen on orbit. And what that means is the spacecraft can preserve propellant and extend its overall mission lifetime. So that's something we worked in coordination with NASA and Lockheed, and something we're really proud to enable for the GOES team.
Ignition and liftoff.
The most recent Falcon Heavy to take off from Florida was also the sixth and final flight for the side boosters 1064 and 1065. Another NASA mission, Europa Clipper, required the full might of the Falcon Heavy rocket to begin its journey out to the Galilean moon of Europa. It's expected to arrive in April 2030 to begin studying the icy moon, thought to have liquid subsurface lakes beneath its icy exterior.
Europa Clipper is the largest spacecraft NASA has ever developed for planetary exploration, and it will be traveling over 1.8 billion miles from Earth, which means it needs a powerful rocket to get there. Falcon Heavy provides over 5 million pounds of thrust and will launch Europa Clipper on an Earth escape trajectory. Falcon Heavy is giving Europa Clipper its all, sending the spacecraft to the farthest destination we've ever sent, which means the mission requires the maximum performance, so we won't be recovering the boosters tomorrow. I don't know about you guys, but I can't think of a better mission to sacrifice boosters for, where we might have an opportunity to discover life in our own solar system. How cool is that?
While Europa Clipper was the final launch of a Falcon Heavy until now in 2026, there were still big things happening behind the scenes. Out west at Vandenberg Space Force Base, SpaceX was working with the Department of the Air Force to acquire the lease for Space Launch Complex 6, the former home of United Launch Alliance's Delta IV rockets. The final launch of a ULA Delta IV Heavy rocket came in September 2022. In April 2023, the Air Force announced that SpaceX would be leasing the pad for its Falcon 9 and Falcon Heavy rockets. The Department of the Air Force announced in December 2024 that it was preparing an environmental impact statement regarding SpaceX's planned use of SLIC-6. And after going through public hearings and receiving public comment, on October 14, 2025, the Department of the Air Force published its final environmental impact statement and a decision of record. The combination now allows SpaceX to not only launch up to 5 Falcon Heavy rockets per year from SLIC-6, but it also increased the number of Falcon 9 rocket launches allowed between both SLIC-6 and SLIC-4 East, up from the previously permitted 70. SpaceX was also permitted to construct a new hangar south of the horizontal integration facility and north of SLIC-6 to support future integration work. The timeline for when this pad will begin supporting Falcon launches is unclear. Meanwhile, back in Florida in late 2025, SpaceX decided to stand down from launching Falcon 9 rockets from Launch Complex 39A and focus explicitly on Falcon Heavy and Starship launches. After the Viasat 3 F3 launch, SpaceX's next Falcon Heavy rocket is set to launch the moon-bound Griffin 1 mission for Astrobotic no earlier than July. This is part of NASA's Commercial Lunar Payload Services Program, or CLPS for short. And then later, in September, another Falcon Heavy rocket will launch NASA's Nancy Grace Roman Space Telescope. That observatory recently finished its final major assembly at the Goddard Space Flight Center in Maryland and is getting ready to head to Florida for pre-launch testing.
Now, our team dedicated over a decade of their lives and millions of hours to make this project a reality. Because of their hard work, I have the privilege of announcing today that we are now targeting an early September launch, 8 months ahead of schedule and under budget. To everyone at Goddard and across all our centers, congratulations. I hope each of you take pride in what you've accomplished.
And there are plenty of other missions yet to come for the Falcon Heavy. Those include NASA's Dragonfly mission, heading to Saturn's moon Titan, and the European Space Agency's Rosalind Franklin rover, bound for Mars, both slated to launch in 2028. And there are several other missions ordered by the U.S. Space Force and the National Reconnaissance Office that will call upon the Falcon Heavy over the rest of the decade as well. With its super heavy lift rocket Starship still in the development stages, the Falcon Heavy will continue to be an important piece of SpaceX's launch portfolio for years to come. Oh, and as for Musk's Tesla Roadster, the latest tracking data assessed by Dr. Jonathan McDowell show it's about 1.62 astronomical units, or roughly 242 million kilometers from the Sun. It's approaching its next aphelion, or the point in its orbit at which it'll be furthest from the Sun. Reporting for Spaceflight Now, I'm Will Robinson Smith.